Hi, I am Siti Aisha and I'm going to present the topic in control volume, which is impact of jet. Introduction. Moving fluid may exert forces on objects in contact with it. To analyze fluid motion, a finite region of the fluid is usually used. These forces can be determined by the use of Newton's second law or by the momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum equation. The study of these forces is essential to the study of fluid mechanics and hydraulic machinery such as water turbine and Pelton wheel. For objective, first, to investigate the reaction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or hemispherical cup. Second, to compare the results from this experiment with the computed forces by applying the momentum equation. This is the setup experiment, which includes the spring, weight band, nut screw, level gauge, target plate, nozzle, inlet pipe, and adjustable feet. Next is procedure. First, level the apparatus and set the level to the balance position. Make sure the jockey weight at its zero setting. Second, place a mass of 0.6 kg on the weight band and turn on the pump. Third, open the bench valve slowly to allow water to impinge upon the target until datum line on the weight band is level with the gauge. Next, calculate flow rate by the collection of water over a time interval. Then repeat step 1 until 4 with different value of flow rate. And lastly, repeat step 1 until 5 with curved plate or hemispherical cup. This is the result for flat plate. And this is the result for hemispherical cup. If we look closely, the maximum possible value of force on hemispherical cup is twice the force on the flat plate. Here is the example of calculation for the first line of table 11.1. For discussion, if we represent J for x direction, the momentum equation in the x direction will be Fj equals to m dot times u2 cos beta 2 minus u1. The equation of force F on the vane is equal and opposite as shown in the slide. For the case of a flat plate, beta 2 is equals to 90 degree, so that cos beta 2 is equals to 0. For the case of hemispherical cup, beta 2 is equals to 180 degree, so cos beta 2 is equals to negative 1. There is a formula, F is equals to m dot times u1 plus u2. If we neglect the effect of change of elevation on the jet speed, the loss of speed due to the friction over the surface of the vane, we can get u1 is equals to u2. So F is equals to 2 times m dot times u1. From the graph, it is clear that the force produced on each of the vanes, flat surface and also the hemispherical cup is proportional to the momentum flow in the jet as it strikes the vane. The value of flat surface is 0.97 joule compared to the ideal value, which is 1 joule. Also, the value for hemispherical cup is 1.92 compared to the ideal value, which is 2 joule, as F is equals to 2J. The error is possibly due to the systematic experimental errors, such as small error in the measured value of nozzle diameter. And finally, conclusion. First, force exerted on the surface increases as flow rate increases. Second, different shape of surfaces give different value of force exerted on the surface. And lastly, error exists in the result due to systematic experimental errors and also losses occur during experiment. That's all from me. Thank you.